Hello everyone, welcome back to the Bird Show. Today we have a very special guest. I'm joined by Abby Couture. She's a student intern from McGill University in Montreal. Hi Abby, thanks for being here.
Hi, thank you for having me.
And our co-host today is Chipmunk, the Ameraucana chicken, coming back for the third time at the Bird Show. So we have a really cool show planned today, and it's going to be talking about bird senses. A lot of people, when they think about birds, they mainly think about the sense of vision. There's the expression a bird's eye view, right? Or they think about the sense of hearing. They think about songs, but they often don't think of birds as having a sense of touch, taste, or even smell. So today we're going to put a little bit of that right. And we're going to be talking to you about the different bird senses in today's segment, Bird Tales. So first, we're going to talk about the sense of sight. Chipmunk here has a little bit of problem seeing sometimes because of her puffy cheeks, but that's not the same for every other bird species out there. Probably the best known are birds of prey for their vision. So eagles famously can see very far, about 8 times as far as a human can. And they can also focus on a rabbit or other animal at a distance of 2 miles. They can shift focus. They can zoom their vision in on an object from really far away. They can also see way more colors than humans can. They can see in the UV spectrum. A lot of birds can see in the UV spectrum, which makes me think about all the things that they're seeing all the time that we can't necessarily see.
Well, I'm personally not as familiarized with bird vision, but I do know that that is, one of their main senses, in addition to hearing, that really makes them a top predator.
I've often thought about UV light also in terms of the birds that we share our homes with. Sometimes, as those of you who maybe have like a bird, like a cockatiel or something like that in their house may have noticed that sometimes they tend to freak out over seemingly nothing. I wonder if they're actually seeing stuff in the UV spectrum that we can't even sense. And in that way, not only are we talking about bird senses, we're also talking about bird extrasensory perception, at least compared to humans, since when they're looking around, they're seeing all kinds of colors and even spectrums that we can't even perceive at all with our own eyes. As far as daytime vision goes, birds of prey like eagles definitely have the edge over a lot of other bird species, as well as humans. But at nighttime, it's owls that tend to have the best nighttime vision. Not only is it because they have the eyes on the front of their head, so they have this really good depth perception and binocular vision, and they can also spin their head 270 degrees around without even moving their body. They also have tube-shaped eyes that contain more rods than the human eye, and it allows them to be more sensitive to light. Their irises will widen and contract, allowing more light to reach their retina at nighttime versus daytime, but the fact that it can even contract at all is what allows them to also see during the daytime. They can't see as well during the daytime. They can't see a lot of details or a lot of color, but sometimes there's nocturnal species that can't see at all in the daytime light, so it's really important to have the iris that will contract. Oh, another fun fact. Owls and other animals with excellent night vision have a reflective surface behind their retina known as the tapetum lucidium. This thin layer allows light to reflect back into the animal's eye after it's already passed through, giving the animal 2 chances to collect an adequate amount of light. Have you ever gone sort of like on a night hike or anything like that, Abby, to where you notice that you see more in black and white at nighttime?
Actually, I have done a couple interesting night hikes. When I was living in the Amazon for a month, we did night hikes every night. We would look out for like different species of snakes and birds and insects. And we actually got to try using kind of nocturnal eyewear to see what it would theoretically be like for nocturnal animals.
Oh, cool.
And I can say it's definitely a lot more fun than human vision at night.
So you know more what it's like to be an owl than maybe even Chipmunk here does, which is really cool. I've noticed at nighttime that you can see a lot better if you look to the side of your eye, because I guess the cones are concentrated in the middle and the rods are more on the outside of the eye structure. So if you can't see something directly at night, if you try to turn your head a little bit to the side, you can tend to see it a little bit better out of the corner of your vision, which is a good tip in case you're out there and maybe hear a scary noise and can't quite look at it if you look at it directly. So speaking of owls, we're going to move on to our next sense, which is hearing. Owls, I thought that they just had really, really acute earbuds or something in the structure of their ear that made them hear so well. But Abby, you discovered it was something else about owls that helped them hear?
I find it kind of interesting that a lot of the amplification that an owl has in terms of their hearing ability, it actually has a lot more to do with the shape of their face, which I found interesting. Owls, like compared to humans, obviously, they have a more of a heart-shaped face. And it basically, the way that their head is shaped, it allows for a greater concentration of that sound incoming into their ear canal, which makes their hearing more acute. Whereas because humans have ears on the side of our heads, it really limits the scope of the kind of sensory information that we are receiving. So I found that it's quite interesting that, contrary to what we would think, there are a lot of other factors that, are affected by our other senses that can make a difference when it comes to things like hearing.
It almost is like they have a satellite dish on their face that allows them to concentrate the noise. Makes me wonder what we would look like if we were more adapted to have better hearing. But so birdsong, of course, is very well known in the avian kingdom. But a lot of people don't realize that birds also use them to hunt, as you said, like with the owls. And barn owls also seem to be quite selective about the kinds of sounds that they detect. After just a few associations, they refine their alarm system to a specific sound of a mouse or a rodent, and that depends on their environment. So they'll get attuned to that specific noise depending on where they live. And birds also use sound to just communicate in day-to-day life, maybe not for mating like through a song, but I'm thinking of like the penguin colonies where there'll be hundreds of birds and they'll have to find and pinpoint the sound of just their particular family members. Like the parents will find their chicks and the chicks can find the voice of their parents. And there's evidence that that happens in also chickens as well, even when they're in the egg, so that they get bonded to the sound of their own parents' voice through the eggshell. And that way they're able to recognize their parents upon hatching before they've even seen them. So I thought that that was also another super sensory way that birds can use their five senses, like sight and hearing, in ways that we don't even think about.
Penguins are a really interesting species. I remember watching it, I think it was Planet Earth or one of those like David Attenborough shows, and they were talking about Arctic penguins, and they had one clip of a father penguin calling out to its baby in like a horde of like thousands of penguins, and the baby bird was able to recognize the parents' vocalizations, and I just found that so incredible.
I think that's amazing, and I used to see that firsthand as a kid. I grew up with a pond, and every once in a while we would collect some of the eggs out of the nests and we would put them in an incubator to hatch them, mainly because there was a lot of predation. There's these big bullfrogs that would kill the baby ducks and stuff like that. But I noticed even with bonding with the babies as they were getting older and they would get used to my voice, they still were always drawn towards the sound of their parents' voice on the pond. And it's like they always knew deep down that they didn't really belong with us. And eventually they'd make their way out on the pond and join the others. But it was amazing how even then, before I had studied all of this, I sensed that they knew who their parents really were. And I felt kind of like an imposter, but I enjoyed my time with them anyway that I had before they would go back to the pond. Let's move on to the sense of touch. So touch is something that people don't often associate with birds, but they do have developed senses of touch, mostly concentrated in the areas that are not covered in feathers. So their beaks, for example, they can feel a great deal in their beaks. That's one of the things that makes it so tragic in like the industrial egg industry and meat bird production industry. They will burn the tips of the beaks, which is really sad to me because there are so many nerve endings concentrated there. The birds need to be able to feel, if they're pecking a worm or trying to even break something into a smaller piece. That's where a lot of their sensory coordination happens, like with our hands. When you think about parrots use their beaks as a tool for all kinds of things. So that makes a lot of sense. And they also do have touch perception receivers in their feet, even though sometimes it seems like they're immune to cold. I mean, you talked about penguins and you see them walking on the ice, and I thought about that as well when I was watching the documentaries. But it turns out they do feel with their feet, just not in as high of a concentration as human beings do. So they do have receptors, but not as many. And that's how they can stand the freezing cold temperatures. You see her yawn?
I kind of want to like trade my dog for a chicken.
Aw.
I mean, not really, but sometimes I wish I could. They just seem like such great companions.
Yeah, she's a very sweet one. Okay, moving on to the sense of taste. So when I was a kid, I used to think that birds didn't even have a sense of taste. I was told that they couldn't really smell anything either. And it kind of makes sense because both taste and smell are connected, at least in human beings and other mammals. But birds do taste. They have quite a few taste buds, and some species have more than others. Humans have roughly 9,000 to 10,000 taste buds, and birds can have anywhere from 50 to 500. Parrots are on the upper end of that. They have closer to 350 taste buds. Taste buds are not the same thing as actual tastes. So the actual tastes of sweet, sour, bitter, those are shared by both birds and mammals like humans. A bird that lives on nectar and fruit will tend to prefer sweet tastes. That might explain where parrots get a little bit more of their taste buds, since they do tend to eat a lot of fruit in the rainforest. The same kind of sweet tastes don't appeal to grain eaters, like my chicken friend here, Chipmunk, although she's been known to snarf some pie, so I'm pretty sure she appreciates the sense of sweet a little bit more than we give them credit for. And a bird that lives on carrion, like roadkill or other dead things, they'll enjoy flavors that human beings would find absolutely repulsive. So sense of taste also depends on who you are as a species and what you eat for your main diet, and what could smell or taste good to one would definitely be repulsive to another. There's also some butterflies and plants that have developed ways to taste bitter specifically as an adaptation for birds, which just proves that birds do have a sense of taste. And bitterness is actually one of the most prominent tastes in the animal kingdom because evolutionarily it's helped us for so many generations to detect whether or not something is toxic and to avoid eating it.
I was doing a little research and found it interesting that hummingbirds also have like a sweet tooth, which makes sense because I guess a lot of people, feed hummingbirds nectar. It makes sense, birds that live in areas where there are more like sweet sources and like higher concentrations of carbohydrates, right? They would be more of a sweet tooth. I think that's really interesting too. In my head, I was thinking, even amongst birds, that there would be those differences, because I think a lot of people would just assume even like, across the species, they would all have the same senses, but like the fact that parrots and certain birds physiologically have those stark differences was interesting to me.
Yeah, and you brought up something that I hadn't even thought of before, which is I wonder when they were saying that parrots have 350 taste buds, if they were studying the nectar feeding parrots. Because like hummingbirds, there's certain species of parrots who make up most of their diet with the nectar of flowers, and their tongues have adapted to this as well, where they'll have actually like a feathery sort of thing on the end of their tongue that helps them lap it up. I'm thinking specifically of lorikeets. I knew one lorikeet, and when I was younger, his name was Rowdy. He definitely earned that name. I think it was the sugar highs and the lows. I would imagine that they would have maybe at least on the high end of the parrot spectrum, or maybe even more. I kind of wonder if they studied all of the parrots. Which parrots did they study? And is there more to explore when it comes to parrot taste?
I think it's interesting too, because, even in humans, we adapt tastes over time. Like, there are acquired tastes, like coffee, I assume there's very few babies that enjoy the taste of coffee, or like certain spices. And then, of course, we have more like cognitive associations that can change our physiology. But, who's to say birds don't have complex cognitive experiences with food and taste? So
that's a very good point. And I know that as we get older, our taste buds tend to die off, and like adults will like bitter taste like coffee and Brussels sprouts or whatever it may be, as compared to kids, because they say that kids actually have more per square inch in their tongue than adults do. And so I wonder if that's true for birds as well. It's a really good a good
Yeah,
question.
the aging component, because I mean, there are definitely foods that I enjoy now, and I just think I feel like I enjoyed this a lot more when I was a kid. Could be other factors
Yeah, the
in
irony of when you're old enough to eat your own cake and then you don't really want to anymore. My dad had told me a story about that, how he couldn't wait until he was a grown up because he was going to get a pie made out of entirely whipped cream, like the kind you put in people's
Oh
face.
yeah.
Yeah, and he thought it was such a shame that they wasted all those. And one day he was going to get one and he was going to eat the whole pie. And he says he got to college and he got the pie thing and the whipped cream, and it wasn't as good as he thought it was going
Not
to
the
be.
same.
The idea tastes a little bit better than the actuality
Hmm.
sometimes. So there's that too. Okay, let's finish up our talk of senses with the sense of smell. So the sense of smell, like the sense of taste, is definitely one that birds do not get enough credit for. And maybe that's because we didn't even start studying the sense of smell in birds until the 1970s. And since then, we've discovered that their olfactory lobes in their brain, so the areas that control smell, are a lot smaller than the areas that they use for vision. But there's a lot going on in those tiny little lobes. And again, it depends a lot upon the species and what they need the sense of smell for in terms of how acute it's going to be. So the brown kiwi has nostrils at the tip of its beak that it uses to sniff out buried food. And some ocean birds can use smell to help guide them to land. And once again, we have vultures like the turkey vulture who need to have a highly developed sense of smell in order to find the odor that tells them that dinner's ready in the form of carrion or other dead animals. And sometimes those dead animals will be hidden under dense canopies or under a lot of leaves on the forest floor, or they can't see them visually and they have to rely on their sense of smell in order to find that food. In more recent years, even just the past few years, Abby, you were telling me that they've made even more discoveries in terms of bird smells.
Specifically, in studying pheromones, which is a very special kind of scent. There's also still a lot of ambiguity around what different kinds of species carry pheromones, even in the animal kingdom. There's been like a lot of controversial research on human pheromones. But bird pheromones in particular are a kind of a hot topic thing, just because for so long, scientists have thought that they were absent in birds. More recently, within the past couple of years, different teams of researchers have been investigating the secretion of preen oil, which is still a little bit ambiguous in terms of its function. But scientists do think that it's the preen oil, it's a kind of secretion that is emitted in the dorsal part of birds' tails that has shown like antimicrobial properties. And I think that that might be a center for pheromone release as well. So specifically, insectivorous birds have shown to actually eavesdrop on the pheromones of their prey, so like insects. This is, I think, a lot of people would think, oh, okay, that's interesting. But it's actually quite ground shaking a little bit because pheromones are thought to only be transmitted within specific species. You know, they're so specific and there's so many of them, such a large variation of pheromones. This is kind of like a curious thing that these birds seem to be doing is they are essentially exploiting these chemical deposits in insects, not only just to like trap their prey, which was initially what the researchers just figured they were doing as a kind of chemical camouflage, but that also might be used in sexual behavior between the birds as well. So there's still emerging research on it because it's fairly new. I think that paper only came out about a year ago, and it's all about, you know, the perfume of reproduction in avian life. You know, so birds could potentially, if this is true, have the widest array of senses among any kind of like class of species.
I had never heard of that. I know that potentially they can sense pheromones between each other, like between the same species. For example, if you have hens, like Chipmunk here, and you have a rooster, then even having them in proximity where they can't see each other can affect the reproductive patterns of the hens. They think that it's also because of hearing the crow, so there's the auditory component as well. But I would argue there's probably some sort of pheromone thing going on. But I had never heard about a bird being able to sense the pheromone of another species. I think the closest example to anything like that that I could even think of in the animal kingdom is some of the dogs that can sense changes in people, like if they are going to have a seizure, or if they have even some sort of cellular tumor or growth like that where they can sense it in human beings. That makes sense because we've co-evolved for tens of thousands of years at this point, where maybe there's some overlap in terms of unconsciously our fear pheromones and stuff like that. I've also met some parrots I feel like could sense fear, but I don't know if they were doing that based off of pheromones or like, subtle visual cues. But I definitely have known a few parrots that will pick on the person that they can sense is the weakest in the flock in terms of having parrot fear to begin with.
I guess they're still needing more replication, but I think that is a really good indicator that maybe there is something else going on here because, a lot of people also confuse like someone's individual scent, right, with pheromones. And pheromones are like a very complex chemical secretion that is typically just involved in sexual reproduction. But, if they're able to sense it in insects, then I assume it's not like, oh, okay, that individual scent of that one insect, right? Like this is something more complex. So, yeah, it's interesting.
The more we discover about bird senses, it's not just the five senses, it's almost like extrasensory perception. That they're not only able to do the five: smell, touch, taste, hearing, and seeing, but they can do them exceptionally well, even better than we realize. Well, thank you for sharing that tidbit about bird pheromones and insect pheromones. Let's move on to the flocking news. The flocking news. Today's flocking news article is called "These Birds Have Been Found to Warn Rhinos of Poaching and It Could Help Protect the Species." This was published April 25th on the Good News Network. And one of the quotes from the article is, "One iconic symbiotic relationship between the rhino and the oxpecker may be providing rhinos with a life-saving early warning system to alert them to the presence of nearby poachers. Poaching is famously hard on rhinos, but the red-billed oxpecker, a bird which you may have seen riding on large mammals like buffalo and rhino while feeding on the parasites that cling to them, may actually be providing alarm calls to help rhinos escape such dangers. While rhinos have a good sense of smell and hearing, they have poor eyesight, and if you stay downwind of the great beasts, you can actually get quite close without being detected unless there is an oxpecker on its back. The bird's Swahili name, Askari wa Kifaru, translates to the rhino's guard, and you can definitely see why, because in this study, they showed 40 to 50% reduction in sightings of rhinos when they were accompanied by oxpeckers. A couple episodes ago on the Bird Show, we talked about helper birds, and we specifically talked about oxpeckers as being symbolic of that symbiotic relationship where both are benefiting from being in the relationship. So this is a whole new twist on it in terms of saving endangered species. I didn't even realize that the oxpeckers were also helping out rhinos. So it's really cool that they're employing their senses to help the rhino where the rhino has a few deficits in their own. And kudos to the rhinos who are picking up on what the oxpeckers are telling them and not just listening to their alarm calls and ignoring them.
Yeah, I think that's really interesting too, to see this case of a symbiotic relationship in the animal kingdom that has like far-reaching consequences in like even the context of human society. It's obviously, rhino extinction is as much a social and political issue as it is an ecological one. So that's really cool that you're seeing that.
It makes me wonder about, who was the first rhino to sort of figure out what the oxpeckers were talking about, because I'm assuming it didn't necessarily start as the oxpecker trying to directly tell the rhino, like, hey, a poacher's coming. I'm assuming what happened was that there was a bunch of oxpeckers and they would kind of warn each other that they saw humans around. And over time, the rhinos associated that with, okay, every time they do that, then people tend to show up. So I'm pretty sure that's what they're saying to each other. I wonder then what was the conversation between the rhinos of like, hey, have you ever noticed that these birds tend to freak out right before people show up? Just makes me wonder how it actually all went down. So that's it for the flocking news. Let's end it with a bird of advice. A bird of advice. So today's bird of advice is that we should all, as human beings, do as the birds do and come to our senses. I think way too often we get trapped in just being visual, maybe even just being auditory and just hearing and not necessarily seeing. There's really so many opportunities in the world where if we engaged all of our senses, our sense of touch, taste, smell, we really, I think, would do well because we would feel more grounded, not only as individuals, but also as a species. You can feel a little bit like you're a floating head and all perception and cognition just from the neck up, but often our bodies have a lot to tell us through our other senses that we aren't necessarily hearing or understanding unless we take the time to listen.
I think that's a really beautiful general piece of advice that we should think about in our day-to-day lives, because yeah, that definitely really resonates with me. And especially times like these, I think it can be very easy to get stuck in, I guess tunnel sensation, and not necessarily tunnel vision, but, we just kind of get lost in a certain way of existing, and to remember that there are so many different ways to be and interact with our environment. I think that's a great lesson.
I think you've brought up a lot of good points here in terms of seeing also sort of beyond what's in your immediate perception. So I'm thinking back to the bird pheromones, and these things are often invisible or subtle or not at all obvious. And so I think tuning in to some of the senses that we don't use as often can help us see the things that would fly by and that we wouldn't even notice, or that would remain invisible to us otherwise. It makes me wonder, even just in studying all these amazing senses that these birds have, how many things I'm missing day to day, and if I could see in UV spectrum, what would the world look like? Yeah, definitely good food for thought. Mm-hmm. Well, that's it for today's Bird Show. Thank you again so much, Abby, for being here and sharing your bird wisdom with us.
For having me.
Yes, anytime. And for everyone, I hope that you've been having a great week, and I hope to see you next week. Until then, have a flocking good time.
Turns on the radio. When Dr. Crow turns on the radio. To Dr. Crow's Bird Show.